I have the review, I have the winter assignment loaded up. I'm my usual plan is not necessarily to go like page by page because that would take way too long. I leave it up to you. What do you guys want me to go over? Have you all started it at least? Yeah? Okay. I forgot to mention it in class, but I did put it on Google Classroom, I believe. There are three questions that you won't be able to do at the very, very end because it's the lesson that we're going to do on Monday when I see you guys. So that's why this winter assignment is due the at the end of the week. So you have that time to do those questions. So it's numbers, I believe, at the very end. Let me see. Yeah, it's 74, 73, and 71. So those three you're not going to be able to do yet. Okay, so don't freak out if you looked at it and you were like, what the hell? Okay, because that's what we're going to be doing on Monday. All right, so I'm leaving it open to you guys. What would you like me to go over? 13, sure. Okay, so for number 13, to find that limit, since it is as it's approaching zero, you have to, and if you plug in zero, right, that's always like the first thing you want to try is just direct substitution. The denominator would be zero. But since you have that square root, that means that we have to use the conjugate method. So you would have had to multiply by 2 plus the square root of 4 plus x to both the numerator and the denominator. So when we multiply, right, you're going to distribute the numerator, which would give you 4 plus 2 square root of 4 plus x minus 2 square root of 4 plus x. And then this is minus the square root of 4 plus x squared. So that the square root will cancel out and it would be minus 4 plus x. Now, I put this in parentheses because since it is minus, we will have to distribute that negative. Does that make sense? Yeah? Okay. So these here cancel, and then when you're doing this method, the conjugate method, you don't actually distribute this x. We're just going to leave it right next to each other because the whole point is to cancel out that x. So what we end up with here is this 4, and then minus 4, and then minus x all over x times 2 plus the square root of 4 plus x. So these 4's cancel. So you're left with negative x over x times 2 plus the square root of 4 plus x. So now the x's cancel, and you're left with negative 1 over 2 plus the square root of 4 plus x. So far, so good? Okay. Now you can go ahead and plug in the 0, because now the denominator will no longer be 0, which would give you negative 1 over 2 plus the square root of 4, which we know is 2. So negative 1 over 2 plus 2, which is 4. So negative 1 over 4. Is that what you got? Oh, um, let's try it. I don't know. You probably can. Those of you that are not familiar, because I haven't taught this lesson yet, L'Hopital's rule, it looks weird. It's like this. Is for when you take a derivative. The thing is that this rule only applies if you end up with either 0 over 0 or infinity over infinity. You got me? In this particular case, if you were, oh, well, yeah, you do get 0 over 0 if you plug in 0. So let's try, right? L'Hopital's rule means that if you're trying to find the derivative and you end up, the derivative, the limit, and you end up with 0 over 0 or infinity over infinity, what you can do is find the derivative of the numerator and put it over the derivative of the denominator. So we would get 2 minus the square root of 4 plus x, which can be rewritten as 2 minus 4 plus x to the 1/2 over x. And if you find that this is the only time, L'Hopital's rule is the only time you don't have to like use quotient rule. You literally find the derivative of the numerator and put it over the derivative of the denominator, which this would be the derivative of the numerator is 0 minus 1/2 times 4 plus x to the negative 1/2 times the derivative of the inside, which is just 1. And it's over the derivative of x, which is 1. So if you clean this up a little bit, we end up with negative 1 over 2 times the square root of 4 plus x. Is this so far okay? And then you can plug in the 0 and you do end up with the same answer of negative 1 over 4. So yes, L'Hopital's rule would apply to this kind of question. I found the derivative of the numerator and the denominator, and I didn't flip it. It's that this part here, sorry, I know it's a bit of a mess. You see how I'm going to clean it up over here, negative 1/2, and then 4 plus x raised to the negative 1/2. And all of this is over 1, so I don't need to write the 1. This is my derivative of the entire thing. Because this exponent is negative, this whole part here moves down to the denominator with the 2, which is why it's this. What other questions do you have? Sure. 21. Okay. So we have the limit as h is approaching 0. Now, anytime you see h in a limit, check to see if it looks like this. The limit as h is approaching 0 of f of x plus h minus f of x all over h. And if you look at it, right, this follows that format. As h is approaching 0, this is f of x plus h minus f of x. And you see how it's all over h, right? So this is supposed to equal to f prime of x. So this limit is equal to the derivative of f of x. So what you have to do with these kinds of questions is you have to identify what is f of x in that limit. Do you know what it would be? No? Yeah, 3 to the x, exactly. So Brittany, does that kind of make sense? Yeah. So once you identify what your function is, then what you can do instead of actually trying to find the limit, because it would be kind of impossible in this particular case, we would find the derivative of f of x, and that is the answer to the limit. Do you get me? So this is 3 to the x, and the derivative of an exponential function where you have x as the exponent, f prime of x, is going to equal to the ln of the base, which is 3, times the exponential function, and then you multiply the derivative of the exponent, which is just 1. So this would be the answer to the limit. No problem. Yeah. Uh-huh. Let me think about this a second. Hold on. So if you are going from 4, like for number 17, the limit as x is approaching 4 from the right, you can, let's say, plug in a number that is slightly to the right of 4, right? So let's say 4 plus 1. Now the reason why, I mean 4.1, the reason why I said you have to know the graph is because typically if it's a one-sided limit, if it's a rational function like number 22, we know that this is going to be either infinity or positive infinity because of asymptotes and stuff like that, right? But this is not a rational function. This is a radical function. So As long as you don't have to know exactly what the graph looks like, but any radical function looks like that. So you should know at least that much. Does that kind of make sense? Okay. Um, and the reason why it's really difficult to try to find this limit without knowing the graph, just because, like, let's say if you plug in a number that is slightly to the right of 4, such as 4 plus 1, it would be 4 plus 1 minus 4, which is the square root of zero point 0.1, and then minus 5. It doesn't really help. Do you get what I mean? So instead, you do kind of have to know that the graph looks like this curve, where it usually starts here at the origin, and then it just goes on forever to the right. And the good thing about this one is just that it's only translations, right? It went to the right 4 and down 5. Does that make sense? Because remember, anything that is added or subtracted inside of the function with the x moves left or right. So since it's minus 4, it's going to the right 4. And then that minus 5 at the end means it went down 5. Does this sound familiar, our transformations? Kind of? Okay. So if this went to the right 4 and down 5, that means that this point, the origin, is at 4, negative 5. Because if it starts here at 0, 0, and then right 4 and down 5, right? 4, negative 5. Yeah? So if I'm coming from the right side, that's over here, we know that the limit would have to be this, the negative 5, the y value. Okay? But, and I'm just going just to finish this problem, right? Because 17 and 18 kind of go together. This is 4 from the left. That's the thing, you have to know that this graph, there is no left. There's only a right side, because the square root, you can't have a negative inside of the square root. So if I'm coming from 4 from the left, there's nothing there. So does not exist. It, that works as well. Yeah, no problem. So I guess as long as you know that it does open forever to the right, then pretty much any limit, I mean, you could figure out the y value for number 17 just by looking at the number that is outside of the radical. Any other questions from this page? No? Yeah. Okay. Okay. Okay, go ahead. Number, yes. Okay. So number 5, we have the limit as x is approaching 3. Like I said earlier, if your first, like, there's 3 methods of finding limits, right? There's the substitution method, factoring, and then the conjugate method. You always want to try if substitution will work, right? So because this is a rational function, meaning a fraction, if you take that x is equal to 3 and you plug it into the denominator, we end up with 0 in the denominator. That means that this is not going to work. So this is a rational function. As long as there's no square root, see if you can factor, right? X squared minus 9 can be factored to x plus 3, x minus 3, because it's a difference of squares, over x minus 3. So these x minus 3's will cancel, and we're left with just x plus 3. So now you can take that number and plug it in. So 3 plus 3 is 6. Yes. Okay, no problem. Any other questions either from this page or the next? So numbers 1 through 22. Okay, number 10. Fair enough. Okay, number 10, we have the limit as x is approaching 2 of x minus 2 over 1 over x minus 1 over 2. Same thing. If you plug in 2, you would get 0 in the numerator, you would get 0 in the denominator. So we know that we're going to have to use a different method or do something to this, right? You could try here, certainly using L'Hopital's rule, right, and see if that works. But I usually just go with the algebra. Whenever you have something that looks like this, and they love using questions like this, where either the numerator or the denominator has fractions, okay, you want to work with, for example, in this case, the denominator and making it into one fraction instead of 1 over x minus 1 half. You get what I mean? Like, instead of having two separate fractions that you're subtracting, you want to turn it into one. Does that make sense? So we're going to focus on that part. We have 1 over x minus 1 over 2. In order to get a common denominator, you just multiply the two denominators together. So the denominator here that we need would be 2x. Is this okay? Yes or no? Okay. So I'm exactly. So this we multiply by 2, this we multiply by 2, and here we multiply x, and here we multiply x. So now I can rewrite this as 2 minus x, and since it's both over 2x, we're going to put it all over 2x. Is this part okay? Now the whole reason why we do that is because now this is my, if I rewrite this limit, it's x minus 2 all over 2 minus x over 2x. Here we have x minus 2 and we're dividing a fraction. So when we are dividing a fraction, what we're doing is we're multiplying by the reciprocal. So this would be x minus 2 times 2x over 2 minus x. Yeah? Okay. Now the whole reason why we do this is we want to see if we can cancel out the denominator because that's where we have a problem. See, if you plug in 2, the denominator would still be 0. X minus 2 and 2 minus x are almost identical. The only thing that's different here is that the signs are all changed, right? In x minus 2, the x is positive, the 2 is negative, and it's the opposite for 2 minus x, where the 2 is positive and the x is negative. So what we can do is factor out a negative from either one, whichever one you want. So let's say if I were to factor out a negative from x minus 2, then that would become negative x plus 2, right? So far, does that make sense? And if you look at negative x plus 2 is the same thing as 2 minus x. It's just the order is switched, right? So I can cancel this with this. And so now all I have is negative 2x. And now I can go ahead and plug in that x is equal to 2. So negative 2 times 2, which is negative 4. Any others? Okay. Let's go ahead and move on to the next page. So we're just going to go page by page. I'm going to ask you what questions do you have from this page and like that, okay? So here for 23 through 27, any in particular that you would like me to review? 24. Okay. State whether the function is continuous at the value or the rule for the function changes. That means this. Since these are all piecewise functions, the rule for which the function changes is this, at x is equal to 1. So you're checking your piecewise function where there's a possible break of continuity. So remember that if we're trying to figure out if a function is continuous, you need to go through your three-step process. The defined value, right? So in this case, right, to find f of 1, where would I plug in the 1, in the top or the bottom? The bottom, because that's where 1 is defined. So that would be 1 plus 1, which is 2. Next, we need to check for the general limit. So this function value is also the limit as x is approaching 1 from the right of f of x. So we already have the limit from the right. Now we need the limit as x is approaching 1 from the left, meaning we're going to plug it in to the top equation. So 4 minus 1 squared, which is just 4 minus 1, which is equal to 3. So because the limit from the left does not equal the limit from the right, that means that the general limit does not exist. So I don't have to continue anything anymore. We would say that f of x is not continuous at x is equal to 1. And we would say because the limit as x is approaching 1 of f of x does not exist. So basically, I mean, if this was like a multiple choice question, this isn't because I have you justifying your answer. But if this was, let's say, just a multiple choice question, you would take the number and plug it into both the top and the bottom. So for example, in 23, if I do 8 minus 2 squared, which is 4, I get 4. And if I plug in 2 into the bottom, I get 6 minus 2, which is also equal to 4. If they both equal, it's continuous. But because this is like a justification process, that's why we're going through the define value, the limit value, and then writing out your statement. Now, what about 25? Is 25 continuous or not? No. Why not? Actually, that's not the reason why we would say it's not continuous. Look carefully at the piecewise function. What is the very first thing you do to check for continuity? F of 3 is undefined. Exactly. You notice here at x is equal, there's no x equals to 3. It's either x is less than 3 or x is greater than 3. It's never x is equal to 3. So right there, you don't even need to plug in anything because at x is equal to 3, f of x is not defined. Yes, correct. You would write, for example, f of x is not continuous at x is equal to 3 because f of 3 is undefined. What about these where you're finding the limit using the difference quotient? This was the long, tedious process. Does anybody remember what is the limit of the difference quotient? Nobody remembers what this is? Yeah, right. That whole thing. Oops. Yes, exactly. Okay, so this is where you're actually finding this by hand, right? So you would need to do x plus h for every single x, work it out, right? Distribute everything. It's a lot of algebra. And then you would subtract all of f of x. Remember, the whole point is to get those h's to cancel out. Did you want to review this one or are you okay with it? Is that a yes? Okay. All right. So this is going to take me a little bit, just saying. All right. So first we need to get the limit, okay, as h is approaching 0, we're going to do f of x plus h. So I'm going to put, wherever I see an x, I'm going to put x plus h. So x plus h to the third minus 5 times x plus h squared plus x plus h plus 6. So this is just the f of x plus h minus all of f of x. So whenever you have minus f of x, make sure you open a parentheses and you write out now your f of x. So that way you don't forget, you're going to have to distribute that negative. And everything here, I'm going to do this to save some space, is all over h. Yeah? Now we have to do all of this algebra. So we have to distribute the x plus h to the third. So you got to multiply everything out. So just to kind of save on space here, I'm going to do it off to the side. Okay, so x plus h times x plus h times x plus h. So if I remember, you can only do two at a time. So this would be x squared plus xh, then plus another xh. So that would, why is this not writing now? Oh, I hate when it does this. Hold on. Okay. So this would be plus 2xh plus h squared. And now we're going to multiply this with the third x plus h. So this would give me x to the third plus x squared h plus 2x squared h plus 2xh squared plus xh squared plus h to the third. And then is there anything that I can combine here? Yes, we can combine this to be x to the third plus, I have this x squared h plus 2x squared h, so plus 3x squared h plus 3xh squared plus h to the third. This okay? So this is just this part right here. So we have the limit as h is approaching 0 of x to the third plus 3x squared h plus 3xh squared plus h to the third minus. Now we have this 5 times x plus h squared. So minus 5, and then x plus h squared is this that I did earlier. You see that? So that's the x squared plus 2xh plus h squared. So I'm just going to go ahead and here distribute that negative 5. So this would be negative 5x squared minus 10xh minus 5h squared. Is that okay? So that's the these two parts here, that's the hardest part of this whole process, because now the rest, this I don't have to worry about, is just plus x plus h plus 6. Now I'm going to distribute this negative, so minus x to the third plus 5x squared minus x minus 6. And all of this is over h. Now let's see what we can cancel out. We have this x to the third and this negative x to the third, so bye. We have the 5x squared and the negative 5x squared. We have this x with this x and this 6 with this 6. So now let's rewrite this whole thing again. So the limit as h is approaching 0 of 3x squared h plus 3xh squared plus h to the third minus 10xh minus 5h squared. And then we have this plus h here as well. And everything is over h. So far, so good? Once you cancel everything out and you rewrite, what should happen is when you look at all of the terms in your numerator, they should all have an h. So that way you can factor out the h and cancel it with the 1 in the denominator. So I'm going to factor out an h from every single term. And that would leave me with 3x squared plus 3xh plus h squared minus 10x minus 5h plus 1. And everything is over h. So now the h's cancel. And now I'm left with just this. I no longer have h in the denominator, so now I can plug in that 0 for h. So wherever you see an h here, if you plug in 0, it's going to be gone, right? Because it's going to get multiplied by 0. So this is 0, this is 0, and this is 0. And we end up with our final answer of 3, whoops, oh, hold on, of 3x squared minus 10x plus 1. And when you do this method, right, you know the power rule, right? If you look at f of x, if you use the power rule, the derivative would be 3x squared minus 10x plus 1. It should match what you got here. Because remember that this limit is the definition of the derivative. Yes, it is. Yes, it is. Okay, and now it says, then write the equation of the tangent line at the x value. Here is my x value, x is equal to 2. So we would take f of 2 to find our point of tangency, which is 8 minus 20 plus 2 plus 6. So I just plugged it into the f of x. 2 to the third is 8 minus 5 times 2 squared, which is 4, so that becomes 20, plus 2 plus 6, which gives me, what is this, 10, so negative 10, negative 4. And then f prime of 2, which is what we have here, 3 times 2 squared is 12, minus 20 plus 1. 12 minus 20 is negative 8, plus 1 is negative 7. So you should get an equation of y plus 4 is equal to negative 7 times x minus 2. Yeah. For the next one, I'm not going to do this whole next one because I want to move on. But when you plug in the x plus h, you're going to end up with these square roots, right? So you would have to use the conjugate method for this one, for number 27. And it's not as long. If we have time, we'll come back and I'll do it for you, okay? All right. Anything in this page? No? Okay. Next page. 40. Yes. Find the following limit. Okay, so this is a limit as x is approaching infinity. We did some questions like this. There, if you remember the lesson on the limits to infinity or infinite limits, whatever, it's the very, very end. It's like the last two slides, I believe. When you have, as x is approaching infinity, then you have a rational and a radical function combination, right? So what you're supposed to do here is you have to divide every single term in the numerator and the denominator by the highest exponent that you have in the denominator. Remember this? This is like the long way of doing it. But for radical and rational functions, you kind of have to do it the long way. What is the highest exponent in the denominator? X squared, exactly. So when you do that, but in the numerator, we have the square root. So when you put x squared into the square root, what is that? No, into the square root. So you're going backwards. You're going inside. It would be x to the fourth. Exactly. So when you are dividing in the numerator, you are dividing by x to the fourth. Is this okay? Because remember, x squared outside of a radical is not the same as x squared inside the radical. You get me? And then in the denominator, we're dividing by positive x squared because this is as x is approaching infinity. If it was as x is approaching negative infinity, we would divide by negative x squared. Remember that x, like when you square root, it's both positive and negative. So it would look like this. Does this look familiar? Because I remember we did this. Yeah? And now we simplify it. So here the x to the fourth will cancel. So this is just 9 plus 1 over x to the fourth over, this is 1 minus 3 over x, because this x cancels with that, plus 5 over x squared. Now, once you've already divided and simplified, now we go ahead and we plug in infinity. But when you plug in infinity, if you ever have infinity in the denominator, that's going to end up being 0. Okay, so like for example here, if I do the square root of 9 plus 1 over infinity to the fourth, 1 over infinity to the fourth, this is just 0. You get me? And then that's going to be over 1 minus 3 over infinity, which is 0, plus 5 over infinity squared, which is 0. So we end up with the square root of 9 over 1, which is just 3. That's if it's a polynomial function. Yeah, but this is, since it's a rational function, that's when you kind of have to go through this whole process. Oh, yeah, that's true too. Hold on, you're right. Because again, like sometimes when I do the answer keys and stuff, I remember I did this answer key last year, so I don't remember what I put on there. But there's always different ways that you can approach the same problem, and I guess I sometimes approach it differently every time. But you're right. If you have a rational function, you can compare the, is that what you were talking about, New York? Comparing the degree of the numerator with the denominator? Okay, you're right. Yes. The degree of the numerator, because it's the square root of x to the fourth, is x squared. And the degree of the denominator is also 2. So then you would take just the coefficients, which is the square root of 9 and 1, and divide. So the square root of 9 is 3, the square root of, and then over 1. So you would still get the same thing, which is 3. Yeah, I just saw it and I was like, I have a feeling. Okay, so here we have 1 over h, the ln of 2 plus h all over 2. Now, when, again, notice that you have 0, right? 0, h. So if you have h, this is probably something along the lines of what we were discussing before, where it's probably the limit of the difference quotient, the whole limit as x is approaching h, blah, 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 right? So if you were to use your, what's it called? Rules of ln and log and stuff and expand, hold on, sorry, I want to make sure I'm explaining it the same way I have it explained here. Yeah, okay. So if you were to work this out, this is 1 over h, and then the ln of 2 plus h divided by 2, that's the same thing as saying the ln of 2 plus h minus the ln of 2. You see how when you're dividing, that's you take this and it's subtracting from the denominator. Does this kind of sound familiar? Like if you have, I'm going to go backwards a moment. If you have the ln of x minus the ln of y, this is the same thing as the ln of x over y. If you have the ln of x plus the ln of y, this is the ln of x times y. Remember these rules? Okay. So, and then again, if I take this one step further, this is the ln of 2 plus h minus the ln of 2 all over h, right? Because this fraction here, if you multiply, it's all over. Kind of. So this is f of x plus h minus f of x all over h. Yeah? If I look at what the function is, this is f of x, right? Now what this actually is, this is f of 2 because they plugged in the number 2. Sort of. So f of x is the ln of x. I want to make sure that you kind of understand. So in this kind of problem, when they have a number that's plugged in, that means to find the derivative of f of x and then you plug in that number. In this case, they plugged in the number 2. So I identified my function, which is the ln of x. Since this is the limit of the difference quotient, which is the definition of the derivative, we take the derivative of the ln of x, which is what? 1 over x. And now I'm going to take the 2 and plug it in. So f prime of 2 is equal to 1 over 2. Any other questions from this page? All right, what about 41 through 54? 47. Okay. For 47, we have the ln of the fourth root of x squared plus 1 over x squared minus 1. You don't have to go through the whole, because you know the derivative of ln is you find the derivative of whatever the ln is, and then you put it over the original function. That's going to take way too much work because you have the fourth root and then you have a quotient. So you're going to have to do a lot of chain rule, quotient rule, whatever, right? So just like how I just showed you guys the rules of the ln, we can do that here, right? So we spend a little bit more time rewriting the function, but it makes it easier to find the derivative. So for example, this is the ln of x squared plus 1 over x squared minus 1 raised to the 1/4, right? This exponent can get moved to the front as the coefficient. So 1 over 4 ln of x squared plus 1 over x squared minus 1. Additionally, this is a quotient, right? And the rules for ln would be 1 over 4. We would subtract. So this would be ln of x squared plus 1 minus the ln of x squared minus 1. Is this okay? So what I've done here is I've rewritten this function to make it easier for me to now find the derivative. Exactly. Yes. I'm not doing chain rule here because that's going to be a nightmare. Now is when I'm going to find the derivative. So g prime is going to equal to, now this 1/4 gets multiplied to everything. So I'm just leaving this 1/4 out, and I'm going to do the derivative of everything on the inside, and then we can distribute it if you want. So we have this 1 over 4. The derivative of x squared plus 1 is 2x, and we put it over x squared plus 1, minus the derivative of x squared minus 1 is also 2x over x squared minus 1. Is that okay? Yeah. Now we can distribute this 1/4, which is what I did in the answer key, I believe. This is already the derivative. If you left your answer like this is fine. But if you want to like keep going or whatever, you can distribute this 1/4, and that would be 2x over 4 times x squared plus 1 minus 2x over 4 times x squared minus 1. So you see how I distributed the 1 over 4 to both of these fractions? And then you can simplify the 2/4 in each one. And I believe that the answer that I have written on the answer key, I actually distributed the 2. So this would be 2x squared plus 2 minus x over 2x squared minus 2. Because I took this 2 and distributed. Any other questions from this page? Yes. Okay. For 41, when you have a problem like this where you have a lot of fractions and stuff, but the denominator is a monomial, so just that one term, bring it up. And remember, when you're bringing up a term, that means that the exponent changes from positive to negative. So what I do first is I'm rewriting the function. I'm not finding the derivative yet. So this is, the 1 stays in the numerator, obviously, and we're bringing up that x to the third. So this would be x to the negative 3 minus x to the negative 1 plus x squared. Does that make sense so far? Okay, and now we can use the power rule. So this would be f prime of x would be negative 3x to the negative 4 plus x to the negative 2 plus 2x. Is this okay? And then we can rewrite this using positive exponents. So we would just bring all of the negative, anything that has a negative exponent down to the denominator. So f prime of x is going to equal to negative 3 over x to the fourth. Only the x goes down to the denominator because only the x has the negative exponent. But the numbers stay in the numerator. Plus 1 over x squared plus 2x. And this would be your final answer. What other questions do you guys have? Any others on this page? All right, we'll go ahead to 53. Sure. Okay, so here we have x squared times log of x to the third. So this is a product. So we have no choice, but we're going to use the product rule because we have two different types of functions that are being multiplied. We have the x squared and then the log. So remember that for the product rule, we find the derivative of the first term, so the derivative of x squared, which is 2x, and we leave the second term alone, so log of x to the third, plus, now we leave the first term alone, so x squared, and now we have to find the derivative of log of x to the third. And as a reminder, the derivative, I'm going to put this here, let's say the log of, I don't know, u, would equal to u prime over u times the ln of the base. Let's just say that's a. Okay? So my derivative of x to the third is 3x squared, and we put that over x to the third. Why does this do this? Hold on. Bro. Sorry. Times x to the third, and then the ln of the base. What is the base for log of x to the third? 10. Exactly. If you don't see a base for log, it's always 10. Okay? Now this can be simplified a little bit because we have this x squared here and then that x to the third in the denominator. So we can cancel out the x squared and remove two of them. So there's just one x left. So my final, oh, and then we can cancel out this x with one of these. So we end up with 2x log of x to the third plus 3x over the ln of 10. So this one is product rule, but then you also have to remember how to find the derivative of a log function. Any others on this page? No? Okay, then let's go to the next page. And the next page is all multiple choice, which is nice. Which one, any of these here that you need help with? Is that a no? Yes. Let f be defined by the function f of x is equal to x plus x squared times e to the negative 2x, on which of the following open intervals is f increasing. So if we're ever trying to figure out when a function is increasing or decreasing, that means that we need the first derivative. So we're going to take f of x, we're going to find f prime. Now to find f prime, this right here, this is a product. So we have to use the product rule because we have this x plus x squared as 1 and then that e to the negative 2x as the second function. So the derivative of this first term would be 1 plus 2x, and we leave e to the negative 2x alone, plus, now we leave the first term alone, and we multiply by the derivative of e to the negative 2x. The derivative of any e function you have to take the derivative of the exponent, which is negative 2, and multiply it by the exponential function itself. So e to the negative 2x. So this is my derivative. Yeah. So now what we are going to need to do is find our critical numbers, which is when the derivative is equal to 0, which can be kind of difficult. So what we're going to do here is we're going to factor out an e to the negative 2x, since everything has an e to the negative 2x. And when I factor it out, I have 1 plus 2x left. That's from here. Plus, and then we have this x plus x squared times this negative 2 that was here. So far, so good. I'm going to clean this up a little bit by distributing this negative 2 and combining like terms. So e to the negative 2x times 1 plus 2x minus 2x minus 2x squared, which these here cancel out. And so we end up with e to the negative 2x times 1 minus 2x squared. Yeah. Now, e to the negative, like e raised to anything, never equals to 0. Okay, I mean, unless you have a number that is added or subtracted or things like that, but we don't. So since it never equals to 0, we can basically just ignore it when we're trying to find our critical numbers. So the only thing that we need to find our critical numbers is this factor here. So we take 1 minus 2x squared and make it equal to 0 and solve for x. So I would subtract the 1, and we have negative 2x squared is equal to negative 1. Divide by negative 2. And then since it's x squared is equal to 1/2, we would square root, which is 1 over the square root of 2. And it's plus or minus, because remember, anytime you square root, it's positive and negative. Now, when you look at your answers here, notice that none of them is 1 over the square root of 2, and that's because it's not rationalized. If I rationalize this, I get plus or minus the square root of 2 over 2. So now I see that it's possibly D, possibly C, but it's not going to be A or B, because it has to involve our critical numbers. Is this okay? Okay. So now we're going to create our number line. We have the negative square root of 2 over 2 and positive square root of 2 over 2. I don't need to know what these numbers are in order to figure out what to plug in. So where's my derivative? Where is it? Right here. This is my derivative here. Okay. Let's say a number to the left of negative square root of 2 over 2. Let's say if I plug in, I don't know, negative 2. Because negative 2 for sure is less than that. Because the square root of 2 is going to be like 1 point something. Divided by 2 is going to be some decimal. So let's say just negative 2, just to be safe. If I plug in negative 2, I will get e raised to the positive 4, so that's a positive number, times 1 minus, and then this would be 1 minus another negative number, so this would be negative. Remember that this, you're only trying to find the signs. Between negative square root of 2 over 2 and positive square root of 2 over 2 is 0. So I'm going to plug in 0. So if I plug in 0, e raised to the 0 is 1. And then 1 minus 0 would be a positive number. And then if I plug in, let's say, positive 2, this would be e to the negative 4, which is a fraction. So a positive. But if I plug in 2 here, I get 1 minus, what is that, 8. So that would be a negative number. So if this is where it is increasing, it is increasing here from negative square root of 2 over 2 to positive square root of 2 over 2. So D. Other questions from this page? Okie dokie. Let's go on to the next. All right, next page for numbers 60 through 66. No? None from here? Okay. And then I guess just the last page. Remember that 73, 74, and 71, don't worry about it yet, okay? Right. You could do 72. Do you want to look at 72 together so that way, you have that at least done? Okay, let's look at number 72. But yeah, see, these are all you're probably looking at like you have no idea what's happening. So don't worry about it. This is the lesson we're doing on Monday. 72. You're not actually doing anything. You're just trying to figure out which one of these matches, like which one of these like statements matches the whatever. Let's just read it. Okay, the temperature of a room in degrees Fahrenheit is modeled by H, a differentiable function of the number of minutes after the thermostat is adjusted. Of the following, which is the best interpretation of H prime of 5 is equal to 2? So before we even look at these options, remember that any time that you are given a derivative, that is a rate. So you're looking for one of these that tells you some kind of rate. And what that means is look at your units. We have here minutes and degrees Fahrenheit. So your rate would be degrees Fahrenheit per minute. So you're looking for wording that has something like that. You get what I mean? Now, additionally, right, this 5, what does this 5 represent? Minutes. So this is 5 minutes. And then we have this 2. What is the 2? Degrees Fahrenheit. Now it's not 2 degrees Fahrenheit, it's that it changed by 2 degrees. Remember, because this is a derivative, so this represents a rate of change. So after 5 minutes, the degrees Fahrenheit increased by 2. That's kind of what it means, by 2 degrees per minute. Does that make sense? So we're just going to look at each option and see, does it fit? It says, the first one, the temperature of the room is 2 degrees Fahrenheit after 5 minutes, 5 minutes after the thermostat is adjusted. We just said it's not that it's 2 degrees, it's that it changed by 2 degrees. So it's automatically not A. Additionally, there's no rate. It's not 2 degrees per minute or anything like that. So for B, it says the temperature of the room increases by 2 degrees Fahrenheit during the first 5 minutes after the thermostat is adjusted. Now this one is like it's there because it sounds like it could be that. It is going to be an increase in temperature because the derivative is positive. So we see that increases, we're like, oh, it's definitely that, right? But it says during the first 5 minutes. It's not, a derivative does not tell you the rate of change during all that time before. It tells you at that moment in time. So at exactly 5 minutes, the rate of change of the temperature is 2 degrees per minute. Does that kind of, I know like the wording can be kind of like annoying, but also what this is telling you is that is the average rate of change, not remember that average rate of change is when you have 2 moments in time and you're finding the slope. But the derivative is the instantaneous rate of change. It is the rate of change at that moment. So it is not B. The temperature of the room is increasing. So increasing, again, we're like, oh, okay, yeah. at a constant rate of 2 over 5. 2 over 5 has nothing to do with anything, okay, because it's just 2. So it's not C. So it's got to be D. But let me explain why. The temperature of the room is increasing at a rate of 2 degrees Fahrenheit per minute. And that is at the moment where it is 5 minutes after the thermostat is adjusted. Okay? So even though, like, when we read it, when you have a multiple choice question like that, go through every option. Make sure that you narrow it down. Don't just like, because initially, like when I read this, I was like, oh, it's going to be B. And then I continue reading, and I was like, oh, it's not B. You get me? So always just make sure that you read all of them. And then don't worry about the rest of that. Okay? Any other questions to wrap up this review session? No? Now, I understand if you guys didn't finish. Remember that this is not due until the end of next week. So you have some time to make sure that you finish it up. Um, so can I stop sharing if we're done here? Okay. If you have additional questions, like throughout the week and you're working and you get to some of these that we didn't do today, just you can always schedule a meeting with me. We can go over it, or I'll carve out some time in the week to maybe go over whatever other questions you have left over before it's due. Does that sound good? Okay, hold on. Before you guys leave, I'm gonna stop recording. Um,